Our first program concerns Bernoulli's principle, named after Daniel Bernoulli, a Swiss mathematician and physicist who lived from 1700 to 1782. The use of Bernoulli's principles makes possible the operation of the car, the airplane, the curved ball, the lift of a golf ball, and the behavior of fluids and gases. We'll start by demonstrating a simple example of Bernoulli's principle, and it is one that you can try at home. So just grab a piece of paper and do what we do. This is our first demonstration here.
All right.
Grab a piece of paper.
I'm excited.
There we go. Now put it right under your chin like this and blow over the top. You're blowing hard.
Oh.
Okay.
I'm not supposed to blow hard?
No, that's fine.
Oh.
We blow. And you notice that instead of the paper being pushed down, it's actually rising up.
Yeah, I noticed.
And if you go real fast like you did, that's a flag blowing in the breeze.
Uh-huh.
Okay. So Oakley's going to show us a diagram of a wing, and this is an example of how an airplane flies.
We have a picture of an airplane wing cross-section, so if you looked at it from the end, this is what you would see, this shape. It's kind of a teardrop shape on its side, a little bit flatter on the bottom than it is on top. When the wing comes through the airflow will be moving around it, as the arrows indicate, and the air on the top of the wing has farther to travel in the same amount of time as the air flowing under the wing. Because it has to go further in the same amount of time, that means it has to be moving faster. If it's moving faster, we get a fast flow, which generates low pressure, and that is Bernoulli's principle. Areas of faster fluid flow give areas of lower pressure. So low pressure on top of the wing, high pressure underneath the wing, this generates an upward lift and allows the aircraft to fly.
So when we blow across the top, there's the air moving across the top.
Faster.
Because I'm not blowing anything on the bottom.
Right. Fast flow, low pressure on top, high pressure underneath gives its lift.
Oh, I get
as
it.
Oakley explained. And you can see why Oakley is the premier physics teacher in the state of Wisconsin.
Indeed. Nicely
Okay.
done, Mr. Moore.
Thank you.
Yeah. Now I think we can do a larger version of that, can't we?
Ooh,
I believe so.
like
Let's
larger.
try that. Let's see now. I'm going to blow over the top of this. Yes. Get the paperwork done here. Blow over the top. Let's see what happens here. Not very much.
Not much, Doc.
You try it. You try it. Okay. Not very much.
You got enough air there, Oakley?
Nope.
No. What we need is more
Air.
air. More air. We have more air. There we go. Let's try that. Now, if somebody had a birthday, we could paper a tree or something like that. Yes.
That's
okay.
how they do that. I never
Yes,
knew.
yes, okay. We're going to take a ball and we're going to levitate that ball. You got a round one? Round one is good, okay. And we'll try to levitate that ball.
Cool.
Okay, try that.
Okay.
It's not easy.
Oh, no, you're right.
It's not easy.
Ooh. Now this is one they can try at home.
That they can try that at home, and some people, mainly college students, will lay on their back and they will put a peanut above their mouth and they'll levitate a peanut. That's a little harder, but it can be done. Okay. Now I squished mine here, but we'll see if it works. Very good, very good. How about a larger version of that? Can we do a little bit version of that?
I think so.
I think we can do that. Okay, so let's see. I have a larger ball, and for a larger ball, we need a larger airstream. Okay. All right. Ooh. Wow. Like magic. Like magic. Okay.
You tilted.
All right. Now, what is going on there?
To the board.
To the
If this is our ping pong ball on top of the hairdryer, when the air is splitting and moving around the ball evenly, it stays balanced right in the center of that airstream. If the ball slips out to one side or the other by too much, let's say in this case it goes to the right, then more of the air will go around to the left, where the fast flowing air is now on the left side of the ball, and on the right side we don't have the fast flowing air. So that means high pressure on the right, low pressure on the left, and the ball will get pushed back into the center of the airstream.
Now you can see that that ball is trapped in there by Bernoulli's principle. And we showed you a small version of a ball on a soda straw. We showed you a bigger version, ping pong ball on hairdryer. And we come back, we'll show you the supersized. So stay tuned.
Why add a man a furnace? It's the last furnace you'll ever own. Why Flox Heating and Air Conditioning? We're here when you need us. Together, we're always here taking care of you. Dependable heat, dependable company. Flox Heating and Air Conditioning. Call today for your free estimate.
Culver's Butterburger Deluxe is made with 100% Midwest beef. Always fresh, never frozen.
In my experience, fresh beef is always better. Frozen beef loses moisture, and when you lose moisture, you lose flavor.
There is an art in making a great burger. The searing really locks in the flavor, just like a great steak. And then we lightly butter the crown of the bun. That's why we call it a Butterburger. How many years have we been working together?
Close to 20 years now.
Welcome to Delicious.
When we come to Warren's Clinic, we like to see Kelly and Tracy out here. They make my kids feel really comfortable. The reason we like coming to the clinic is because we can get in the same day. We've been seen at the Warren's Clinic for things as simple as a cold, and the kids have had pneumonia and been in a couple times. I would recommend going to the Warren's Walk-In Clinic. The staff is friendly. You'll be in and out before you know it.
Toma Memorial Hospital, taking care of you.
Why add a man a furnace? It's the last furnace you'll ever own. Why Flox Heating and Air Conditioning? We're here when you need us. Together, we're always here taking care of you. Dependable heat, dependable company. Flox Heating and Air Conditioning. Call today for your free estimate.
Solve many of life's problems with these tools from All-American Do-It-Best Rentals in Toma, Sparta, and Richland Center. The Excavator, compact in size, has a 24-inch bucket and digs over 11 feet deep with easy-to-master controls. The Wood Chipper, it's operator-friendly, handles 6-inch material and is self-feeding and easily tows behind a trailer. Just some of the problem-solving tools from All-American Do-It-Best Rentals in Toma, Sparta, and Richland Center.
And welcome back. Now you saw how we levitate a ball, and we'll review that one more time. And you can see that when we have the ball above the airstream, ooh, that's very good. That if it gets to one side, the airflow is faster than on the other side, and that creates a high pressure, a high pressure on one side, a low pressure on the other. So it's really trapped in there by Bernoulli's principle. Now we've gone from small to medium, now we're going to go to large. And we have a large ball, and the question is, can we levitate a large ball like this?
Let me try.
Yes. I don't think that's working.
Nope.
Do we have a bigger airflow, Oakley?
I think we do.
We do. We do. Okay. All right. So Oakley's going to put that down because this ball is going to go up there. I will put this ball above it. Airflow, please. Full airflow. Okay. Fantastic. Ooh, oh, okay. Now you saw how that worked. The airflow on one side being more than the other, and it was trapped in there by Bernoulli's principle. We want to show another example of that, and that is a curveball. And well, the Brewers could use better curveballs, couldn't they? Okay. So what we're going to do is we're going to show how a curveball is thrown by a pitcher, and he or she will put a spin on the ball. Usually it's a top spin, so the ball is spinning like this. And that means that as the ball is spinning, there'll be a fast flow, low pressure on the bottom, high pressure on top, and the ball will go down. Well, we're going to make it go like this, coming off a device here that has a grip material. It has sandpaper, so that when it comes off of here, it'll be spinning around like this. Fast flow, low pressure on this side, high pressure on this side will make the ball go to the right. Would you like to see that?
Yes, please.
Let's try that.
Okay.
All right. You have one? Okay. And here we go. We'll go right at the audience. Be careful, audience. Here we come. Ooh. Oh. Let's try that again. So we can see that again going right at the audience. Ooh, and we see that it went to the right there. Now, if you're left-handed, that's not easy to do, but I'll try. That means it'll go to the left then. Try that. Yes, it's an attempt. Ooh, that was a fantastic curve there, see? So that's the curve ball in baseball. They throw a curve ball. Now, another example of Bernoulli's principle is the vacuum cleaner.
Really?
It is.
How so?
Well, let's show that. Okay. Now, we have some debris here. Debris. Let's put some debris out here like this. A lot. Oh, that's good. Okay. We want to count those because, you know, budgets are tight these days. Now, if we take one of these, this is a standard, it's called an Aurora tube or Bluegill tube. It's a toy that's been around for some time. You go around like this and it's going to make a sound like that. And the reason that that happens is that the end here is going fast. So across the end you have a fast flow, low pressure, higher pressure on this side, so whatever is down here is going to go from low to high pressure to low pressure there. And so we put this down in here, anything that's down here will be sucked into here like this.
No way.
Yeah, try it. Okay, and Oakley will try that one. So put it down in there, go around real fast. Let it, oh, I'm getting all dirty here. Lift it up a little bit.
Oh, you got to have the air flow.
You got to have the air to flow there, yes.
Let's try this again. See if I can't knock myself in the head.
Okay. Oh, that's fantastic. Now, Oakley has one that is actually a sump pump hose, and it'll do the same thing. So we put it down in there. We go around real fast, down into the, oh, very good, very good. Now, of course, at home, you don't vacuum that way, okay?
I wouldn't recommend it.
What you have at home is that you have a motor down here that blows air across this end. And that fast flow, low pressure means there's high pressure on this end, so whatever is down in the carpet or whatever is going to be sucked up, if you will, and go from the low pressure to the high pressure there. So that's how a vacuum cleaner works. We're going to go to the carburetor, and that doesn't look like a carburetor to me.
No.
Tess, it kind of looks like a jar of water and some soda straws.
That's what Oakley told me to get, though. So.
That's what and he's very smart. Okay, so I'm going to try to show how a carburetor works. I'll take this soda straw and put it down in the water, just colored water. Kind of hold it like this, and then I'm going to blow over the top, like so. Now that's not very efficient, so we're going to use the other straw and blow over the top like so. And you can see the fast flow of air over the top means that there's low pressure, higher pressure on the water comes up, mixes in that fast moving airflow, and then the water goes and sprays out, sort of atomizes it, breaks it up into small drops. Now the carburetor of your car works the same way. There's a narrowed section, it's called a venturi, and that narrowed section has a fast flow of air, and off to the side sits a little bucket of gasoline with a little sprout like this, and so that gasoline is sucked out of that bowl, mixed in the fast moving airflow, and then goes to the carburetors for burning. That's how a carburetor works. Now it's gasoline that they actually use, not water, of course.
Well, that's probably smart.
Yes, okay. Now when we come back, we will show you a large version of the carburetor.
Are we going to get wet?
No, we will not.
Okay. Will our audience get wet?
They may.
Okay.
Okay.
Why Anamana Furnace? It's the last furnace you'll ever own. Why Flox Heating and Air Conditioning? We're here when you need us. Together, we're always here taking care of you. Dependable heat, dependable company. Flox Heating and Air Conditioning. Call today for your free estimate.
Call Culver's Butter Burger Deluxe is made with 100% Midwest beef. Always fresh, never frozen.
In my experience, fresh beef is always better. Frozen beef loses moisture, and when you lose moisture, you lose flavor.
There is an art in making a great burger. The searing really locks in the flavor, just like a great steak. And then we lightly butter the crown of the bun. That's why we call it a butter burger. How many years have we been working together?
Close to 20 years now.
Welcome to Delicious.
When we come to Warren's Clinic, we like to see Kelly and Tracy out here. They make my kids feel really comfortable. The reason we like coming to the clinic is because we can get in the same day. We've been seen at the Warren's Clinic for things as simple as a cold, and the kids have had pneumonia and been in a couple times. I would recommend going to the Warren's Walk-In Clinic. The staff is friendly. You'll be in and out before you know it.
Toma Memorial Hospital, taking care of you.
Why in a man a furnace? It's the last furnace you'll ever own. Why Flox Heating and Air Conditioning? We're here when you need us. Together, we're always here taking care of you. Dependable heat, dependable company. Flox Heating and Air Conditioning. Call today for your free estimate.
Solve many of life's problems with these tools from All-American Do-It-Best Rentals in Toma, Sparta, and Richland Center. The Excavator, compact in size, has a 24-inch bucket and digs over 11 feet deep with easy-to-master controls. The Wood Chipper, it's operator-friendly, handles 6-inch material and is self-feeding and easily tows behind a trailer. Just some of the problem-solving tools from All-American Do-It-Best Rentals in Toma, Sparta, and Richland Center.
And welcome back. We've been talking about Bernoulli's principle, showing several examples of it. And the last one we showed you was how the carburetor works to mix gasoline and air in a car, truck, or motorcycle. But what you want to see is a larger version of that. Do we have a larger version of that? We do. We do. So first of all, we have larger water molecules and we need a bigger airflow. Do we have a bigger airflow?
Once again, we do.
We do. Okay. And let's try that out. Let's see how that works. So here's our airflow. Now, as you can see the air coming right through here. And that means that across the top here, there's a fast flow of air. Fast flow here means low pressure. Anywhere else is high pressure, including down here. So anything that's down here is going to go from the higher pressure to the lower pressure. It'll raise up anything, like before it was the water. Now we have our larger water molecules. So let's try that.
They're not very wet, Doc.
No, they're not, but they're still molecules,
Okay.
kind of molecules. So let's try that. I'll kind of hold on to this. Let's let her go. Ooh. 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 I think that's perfect.
Yeah.
There's molecules all over the place. It's the same idea, ladies and gents. Fast flow of air, low pressure, high pressure down here. They go from the high to the low pressure, raise up and come out here. This way you can see those molecules at work. Now we have 2 light bulbs. You at home could use 2 soda bottles or soda cans. And it's sort of a counterintuitive idea. If you blow between those 2 light bulbs, and what do you think will happen here? Tess, what do you think?
They would move apart.
Oh, that's very logical, isn't it?
You would think so.
Mr. Science Teacher, what do you think? Something a little bit different maybe?
I think that they might come together.
They might come together. So we have 1 vote.
Counterintuitive.
Well, I had to go opposite what you said, right?
So we have 1 vote for further apart, 1 vote for closer together. I'm neutral on the issue, see? So we're going to try that and see what happens. Tess, would you like to blow between the 2?
Why, sure.
A fast blow of air right between the 2.
Okay.
Oh, Oakley was
Yeah.
right.
All right.
They did come together. Now, of course, why did that happen? Well, when Tess blew between the 2, we had a fast flow. Fast flow means low pressure. High pressure on the outside brought them together, and they cling together. And the reason we use light bulbs is not only can you see it, but you can also hear that there's that nice tingle to it. We got a little challenge here. And the challenge is to take a coin and put it in the cup without touching the coin. Can't touch the coin.
Sounds like a magic trick.
Done.
Hey!
That's not quite what you had in mind. Any ideas here? Any ideas?
Well, you got a stick,
A stick, a cup,
and a coin.
a coin. That's maybe illogical. Okay. Maybe there's another way of doing it. Maybe you could set that up there, Oakley, for Tess.
Well, I think we could use Bernoulli's principle. So, Tess, how do you think you could use Bernoulli's principle with this?
Well, we're using a lot of air for Bernoulli's principle, so I'm going to guess I got to blow on that.
Very good.
Seems like a good guess. Let's try it out.
Where are you going to blow?
On the coin.
On the coin. Blow down, blow underneath, blow to the side, blow over the top.
Over the top?
Over the top.
There we
Okay,
go. All
okay.
right.
So you blow over the top. Okay, try that
Apparently I
another.
wasn't blowing over the top.
Okay, big blast of air. Okay, move it back a little bit more, a little further away. Very good. Yes. And see, she did not touch that, but there was a fast flow of air over the top of the coin. That means low pressure. Underneath the coin was the high pressure. The higher pressure raised it up. And then, of course, the air was blowing it into the cup also. So we put a coin in the cup without touching the cup and touching the coin either. So our next thing that we're going to try here is a coffee cup. And I like this coffee cup because I like coffee, and I can put a cup of coffee in here, turn it over, and have another cup right here.
That
Now-
doesn't seem logical.
Well, a 6-year-old, when we were out, a 6-year-old told me that wouldn't work because the coffee would come out, and that seems logical there, see? But what we're going to do is, if you take these two coffee cups glued together, and you can glue them together, you can tape them together. If I just drop it, it falls. And you expect that to happen. That's Mr. Gravity at work here. But if we put a backspin on that coffee cup, we can have it levitate for some time. So let's try that. We're going to stretch a rubber band. So you can see I'm stretching a rubber band here. Going to bring it over the top like this. And then I'm going to stretch it out here so that when I let go, and we all let go of the coffee cups, they will come off the rubber band. They'll have a backspin like this, the way a golf ball has a backspin off the tee. So let's do that. 1, 2, 3, and go. Oh, very good. Very
you guys
good.
are pros.
Well, we've done it a few times, and it's not easy. This has to come out the bottom.
Oh, maybe that's my problem.
Yeah, no, once around,
Okay.
and now turn it over.
Yep.
But get your fingers out of the way. Okay, try that. Okay.
Fail.
It does work though.
Okay.
Okay.
Well,
2 out of
it
3 is
worked
not
for
bad.
you
That's
guys.
pretty good.
Here on our diagram, we have a golf ball, very similar to the coffee cups that we just used in the previous example. A golf ball, when it is hit, has backspin on it, so in this case, the ball would be moving from left to right. The backspin indicated by the arrows directly around the golf ball. Now, the golf ball has all those dimples in it to grab even more of that boundary layer air in its backspin. So we have a little bit of air around the outside of the golf ball going in this direction, rotation. And then this is the air that the golf ball is going through as it moves through the air. And so on top you can see we have air flowing in the same direction. Those two arrows would add together and give you a bigger airflow. And underneath we have arrows in opposite directions which are going to subtract, meaning we have less airflow. So more airflow on top, faster flow, low pressure, less airflow underneath, higher pressure. This generates lift and allows the golf ball to travel further than it would without any spin.
When we come back, we'll give a conclusion and talk about the different things that we did with Bernoulli's principle.
And then we got some toys.
Oh yes. Should we go right to those?
No, when we come back.
When we come back. Okay, we'll do that.
Are you tired of the high cost of fossil fuels? With a water furnace geothermal system, Fox Heating can help you capture the free renewable energy stored in your ground. Remember, no one can raise the price of Mother Nature. Call Fox Heating and Air Conditioning today for your free estimate.
Culver's Butterburger Deluxe is made with 100% Midwest beef. Always fresh, never frozen.
In my experience, fresh beef is always better. Frozen beef loses moisture, and when you lose moisture, you lose flavor.
There is an art in making a great burger. The searing really locks in the flavor, just like a great steak. And then we lightly butter the crown of the bun. That's why we call it a butter burger. How many years have we been working together?
Close to 20 years now.
Welcome to Delicious.
When we come to Warren's Clinic, we like to see Kelly and Tracy out here. They make my kids feel really comfortable. The reason we like coming to the clinic is because we can get in the same day. We've been seen at the Warren's Clinic for things as simple as a cold, and the kids have had pneumonia and been in a couple times. I would recommend going to the Warren's Walk-In Clinic. The staff is friendly. You'll be in and out before you know it.
Toma Memorial Hospital, taking care of you.
Why in a man a furnace? It's the last furnace you'll ever own. Why Flox Heating and Air Conditioning? We're here when you need us. Together, we're always here taking care of you. Dependable heat, dependable company. Flox Heating and Air Conditioning. Call today for your free estimate.
Solve many of life's problems with these tools from All-American Do-It-Best Rentals in Toma, Sparta, and Richland Center. The Excavator, compact in size, has a 24-inch bucket and digs over 11 feet deep with easy-to-master controls. The Wood Chipper, it's operator-friendly, handles 6-inch material, and is self-feeding and easily tows behind a trailer. Just some of the problem-solving tools from All-American Do-It-Best Rentals in Toma, Sparta, and Richland Center.
And you can see now Bernoulli's principle in review is wherever you have a fast flow of fluid, it can be air or liquid, fast flow always implies a low pressure. So fast flow, low pressure, think in those terms. You can see that Bernoulli's principle is involved in every aspect of daily life, from the lift of an airplane wing to the carburetor in your car, the curveball in baseball, vacuum cleaner, the waving of a flag in a breeze. Ooh, what do we got here? Some toys to play with, huh?
Yeah.
Well, let's try some of these here. Here's a Bernoulli toy, and there's a lot of Bernoulli toys out there. We'll blow hard.
Mine's
Oh yeah,
broken.
I'll just blow hard, real hard. Very good, excellent. String impaired, I see. We have a croc or an alligator, and we're going to levitate the eyeballs. Really levitate. Okay. We have a Frisbee. All Frisbees rely on Bernoulli's principle. A Frisbee is part wing, part airfoil, part gyroscope. This one's a very floppy one, but it'll go flying. Okay. We have, what do you have over there, Oakley?
We have a gun that will shoot a ring, similar to the Frisbee, but it's hollow in the middle, and this one's going to fly vertically rather than sideways like the Frisbee.
Oh, I'd like to see that.
So we'll pull back the spring.
Ooh, very good.
That went faster than I thought it would.
Yeah, that's good, very good. But notice it stayed on line because it's spun. That's a gyroscope.
Like a football.
This is a fancy car.
This is a car. Let's see if we have it wound up here. When I was a boy, we used to have a lot of toys like this. Wind-up toys. Now they're electronic. Woo! Ooh. I'd say about 5 miles an hour. Okay, send that back. Ooh. Very nice. Oh, just in time. We hope you enjoyed this science show. Tune into our next program, where we will explain Newton's laws and why the automobile crashes can become severe, and how you can reduce the risk of injury during one. From the lab, so long for now. Ooh, interesting. Success.